Welcome to today's Explainer. Today, we're tackling a really exciting masterclass tutorial on how to bridge that massive gap between high-level business dreams and the actual nitty-gritty technical implementation. We're going to unpack the entire world of architecturally significant requirements, or ASRs, and see exactly how the best software systems are truly built.
Okay, let's dive into this. Consider this completely crazy statistic. Researchers have found that literally only 40% of software features are actually ever used, and that includes highly critical applications. That means the vast majority of your time, effort, and budget could just be going toward things that don't fundamentally drive your system's success at all.
So, that brings up a huge question for us, right? If you're designing or managing software, how do you identify what truly matters in your system? How do you separate the absolute essential foundation from all the extra noise? Well, that is exactly what finding your architecturally significant requirements is all about.
Here's a quick look at our syllabus for this masterclass. First, the core concept explained. Second, finding architectural drivers. Third, converting goals to ASRs. Fourth, mapping with utility trees. And finally, we'll wrap up with the Agile architecture sweet spot.
All right, Section 1, the core concept explained. Because let's be real, not all requirements are created equal.
So what makes a requirement significant enough to actually care about? Basically, an ASR is a requirement that has a profound, undeniable effect on your architecture. It means that if this requirement were somehow missing, your entire system architecture would look dramatically different. If you miss an ASR early on in your planning, you are essentially guaranteeing that you'll be fundamentally rewriting your system later.
And the difference between the two is pretty wild. A simple functional requirement is just, the system should be able to create an order. It's straightforward. But an ASR, something like the system must detect fraud in real time, that is a completely different ballgame. It entirely changes the shape of your software, dictating your processing speeds, your data pipelines, and your immediate action mechanisms.
Moving right along to Section 2, finding architectural drivers. Where do these crucial ASRs actually hide, and how do we systematically extract them?
You essentially have three primary hunting grounds for ASRs. First, requirement documents, where you're looking for priority rankings. Second, interviewing stakeholders, which is usually done through structured brainstorming called quality attributes workshops. And third, understanding business goals, where we use frameworks like PALM to derive hard technical needs from really broad business aspirations.
Okay, Section 3, converting goals to ASRs. This is the absolute core of our explainer. Let's get hands-on and translate some abstract desires into concrete blueprints using that PAL methodology. It's a three-step process. Step 1, identify the high-level business goal. Step 2, translate that into specific quality attributes. And Step 3, refine those attributes into testable ASRs.
Now, what's really fascinating is seeing this tutorial play out in the real world. Let's look at the BHIM app case study. The Indian government had this incredibly ambitious business goal: radically speed up cashless transactions across the entire country. But obviously, a software engineer can't just jump in and code a vague political goal. We have to translate it first. For a massive, diverse population to adopt an app quickly, it needs exceptionally high usability, meaning super simple steps. And because it's handling money on a national scale, it requires absolute ironclad security, which translates to three-factor authentication. Boom. That abstract government goal has now given us our concrete architectural drivers.
But once you've identified all these quality attributes, you have to organize the chaos. That takes us to Section 4, mapping with utility trees.
A utility tree is basically just a fantastic tool to take broad concepts and narrow them down into highly testable targets. Let's take a broad attribute like performance. We refine that down to transaction response time. And from that, we get our exact ASR. Completes in less than 0.75 seconds at peak load, and we mark that as high priority. We do the exact same thing for usability and security. We've officially moved from vague ideas to highly specific engineering targets.
And getting to this level of specificity forces you to make crucial design decisions early. For example, if we have a requirement for an audit trail, should we use a simple file or a complex database? Well, it depends entirely on the hidden ASRs. Are we just passively storing data, or are we going to perform complex rapid analysis on it later?
Probing these requirements deeply is what reveals your actual architectural drivers. If we have third-party interactions, what specific communication mechanisms are supported?
If we need notifications, are we sending an SMS, an email, or just tossing it in a message queue? Does the system need an explicit acknowledgement, or is it just a one-way alert? Answering these questions absolutely dictates your architecture.
Which leads us to our final section, the Agile architecture sweet spot.
We've got to address the elephant in the room here. How does all this heavy, upfront planning actually fit into modern Agile methodologies? There's a really natural tension. Agile is all about responding to change and getting working software out quickly. So it might seem like hunting down ASRs is this slow, traditional approach that's just going to drag Agile down.
But let's look at the data, because it tells a totally different story. When you analyze the time devoted to initial architecture versus the time added later for rework, the truth is super clear. Doing that upfront architectural work significantly reduces the painful, expensive rework needed down the line.
However, that sweet spot completely shifts based on your scale. For a small 10,000 line of code project, the sweet spot is far to the left. You need very minimal upfront work. For a medium project, it's about 20% of your schedule. But for a massively complex 1 million line project, that sweet spot shifts dramatically to the right. You absolutely need to dedicate roughly 40% of the schedule for initial architecture. As your complexity scales, planning becomes paramount.
This is the Big Design Upfront, or BDUF, model for Agile. And the key takeaway here is that having an upfront modeling phase doesn't restrict your Agile iterations at all. Actually, scratch that. It fully supports them. It gives your daily and weekly sprints a completely solid, unbreakable foundation of prioritized work to build upon.
So what does this all mean for us? Architecture and ASRs are not the enemies of Agile. They are the exact foundation that makes scaling Agile possible. Think about it. In an enormously complex 1 million line Agile project, how do you even survive without an architecture to guide and organize the effort? It's something to deeply consider as you kick off your next big system. Thanks so much for joining me for this explainer, and keep building with purpose.